Assalamu alaikum. Welcome to my channel. I am Jahangir Alam. Today I am going to discuss about waves. What is wave? Wave, i- when a periodic disturbance occurs in any physical medium or free space, then they are produces a wave. So, wave হচ্ছে একটা ডিস্টারবেন্স যখন একটা ফিজিক্যাল মিডিয়াম অথবা ফ্রি স্পেসে যখন একটা পিরিয়ডিক ডিস্টারবেন্স হবে তখন সেখানে একটা ওয়েভ জেনারেট করবে। Wave is a means of transferring energy and information from one point to another without there being any transfer of matter between the 2 points. So wave energy transfer করে, that's why it is very important. So wave is a means of transferring energy and information from one point to another without there being any transfer of matter between the 2 points. There are two types of wave according to the angle between the direction of vibration of the medium particle and direction of propagation of the wave. Waves are two types. One is transverse wave and another is longitudinal wave. Transverse wave. If transverse waves are the waves where the direction of vibration of the medium particles is at 90 degree to the direction in which the wave travels. That means here the direction of vibration of the medium particles is up and down, and wave propagate horizontally. So angle between them is 90 degree or perpendicular. So example of transverse wave is water wave. Water wave is the example of transverse wave. Here the molecules of the water vibrates ups and down, and water wave propagate horizontally. So angle between them is 90 degree or perpendicular. That's why water wave is a transverse wave. Now longitudinal wave. If the direction of vibration of the medium particle is same or at 0 degree, then that type of wave is longitudinal wave. So longitudinal waves are the waves where the vibrations of the particles are along the direction in which the wave travels. So here angle between the direction of vibration of the medium particle is same as or parallel or anti-parallel to the direction of propagation of the wave. Here the direction of vibration is to and fro and wave propagate horizontally, so angle between them is 0 degree. So sound wave is the example of longitudinal wave. Look at the slinky spring here. Here the direction of vibration of the spring is same as the direction of propagation of the wave. Describing a waves. First, number one parameter, amplitude. What is amplitude? Amplitude is the maximum movement of the particles that make up a wave from their rest position. So the magnitude of the maximum positive or negative displacement from its equilibrium position of a wave executing particle is known as amplitude. It is denoted by capital A or small a. Unit is meter or centimeter, but SI unit is meter here. So look at the diagram here. It is a transverse wave. Equilibrium, this is the rest position or equilibrium or mean position. The maximum displacement, positive displacement, is shown here by a red color. That means the magnitude of the maximum displacement, positive or negative, from the equilibrium or rest position is known as amplitude. Now wavelength. Wavelength is the distance between one wave peak and the next wave peak along the path of the wave. So the wavelength the distance traveled by the wave to make a complete wave is known as wavelength. It is denoted by the Greek letter lambda. Lambda. So we can also define wavelength by an alternative definition. The distance between two successive crests or trough is known as wavelength. So look at the diagram here. So distance between two successive crests. Crest is the peak position, positive peak position of the wave executing particle. So and the negative peak position is known as trough. So distance between two successive crest is known as wavelength. Also distance between two successive trough is known as wavelength. Now frequency is the number of wave peaks that pass a form in 1 second. So frequency, the number of complete wave within 1 second, is known as frequency. It is denoted by small f. Frequency unit of frequency is hertz. Hz, H capital letter, Z small letter. 1 hertz equal to 1 peak per second. That means if one complete wave is produced within 1 second is known as 1 hertz. 1 hertz, 2 hertz means 2 peaks per second, so on. 1 kilohertz means 1000 hertz. Time period. The time required to make a complete wave is known as time period. It is denoted by capital T and unit is second. So there is a relation, time period equal to 1 by frequency. So we can write capital T equals to 1 by f, or f equals to 1 by t. Also write this way. Look at the question. Calculate the frequency of the wave of time period 8 seconds. So here capital T is 8 second. We have to find out the frequency. We know small f frequency equal to 1 divided by t. So 1 divided by 8, so 0.125 hertz.